So, hello everyone, and welcome to my session, which is the first session of the Z9's online conference of 2020. And let me briefly introduce myself. So, I'm Peter Foldhazi Jr., and I've been with the company for more than 8 years now. And I started working for EPAM Systems uh, in Hungary in their Budapest office. And after approximately 7 years, like 1.5 years ago, I moved to the US to continue working for EPAM here in the States. And I'm really happy to be here. Now it's very different, and it's a lot of different challenges that I'm facing now. And today, what I want to share with you is connected to what I'm doing here and what I've been doing in Hungary as well. And it's just a little part of it. So the whole concept is, I think, is going to be easy to understand. It's going to be easy to incorporate into your new projects. And hopefully, this is something that you can use in your current projects as well to improve your test automation. Um, so going into the details of today's agenda, I sliced it up into three bigger topics. And the first one is going to be the architectural basics. Then I'm going to talk about some of the legacy layering techniques that are still being used, or hopefully not everybody is using them. And I'm going to talk about the main topic, the tri-layer testing framework. And so the reason why I would like to start with the architectural basics is because I don't know the level of my audience. Uh, Last time when I talked about the flow model pattern, there were more than 300 people who joined live online, and I know that there were several other hundreds of people who watched it on YouTube and in the internal EPAM video portal as well. So I know that some of you are juniors, some of you are lead or seniors, and some of you are not test automation engineers. So I would like to give you an overall overview of architectural basics and coding and development basics as well. So first things first, as the main topic is the tri-layer testing architecture, I would like to ask you what you think is important from testing framework. So I give you 10 seconds to think about a list of requirements that you have from testing frameworks. All right. I hope that you had enough time to think about some of the requirements that you have towards testing frameworks. And I'm going to show uh, the list that I came up with. Of course, this list is endless, but I wanted to give you some ideas what I believe are important. So when we talk about testing framework, most of the time we talk about automated testing frameworks. And of course, the primary reason why we create testing frameworks is to automate tests. So that's the first requirement. Then, of course, detailed logging is important in order to be able to find issues. Either it's an issue in our own solution, our test automation solution, or it's a bug, an actual bug that we would like to dig deeper into the technical details, why it's failing. So it helps us in the root cause analysis. Then it's generated reports. Obviously, we would like to be able to uh, show the results, and of course, this can be just pass or fail, but it can be run execution time and many other details as well. And of course, we can generate fancy reports with all sorts of different colors. So after that, I think it's also important that we have integration to a pipeline. Now I think DevOps is also very closely connected to quality and to test automation. So it's a different set of tools, but still test automation engineers, I think they should at least have a little bit of knowledge about CI/CD, and their test automation solution needs to work in the pipeline. If it runs locally and if it runs when you like click on it or manually start the whole execution, that's not full automation. That's half automation. And of course, what the business is really looking into is lowered costs, lowered maintenance costs, quicker to learn the whole solution, quicker to implement new test cases, quicker to ramp up new people on the project. So these are all very important aspects of a testing framework. And there are a number of things we can learn that can help us improve our solution. So think about test automation solution as an actual software. So this is a software development, but it's developed to make sure that you can check the quality and test another software. So one of the keys here, I think, is knowing the solid principles. So I'm not going to go into details with them. If you haven't heard about the solid principles, make sure you to Google it out. There are a number of very good examples. Even on Wikipedia, it's very well described. And it's also part of the ISTQB advanced level test automation engine. So it's also included in that syllabus, and you can be sure that at least one question is related to the solid principles as well. So if you follow these principles, you will have a cleaner code and better architecture as well. The gang of four design patterns is what people in general think when they talk about design patterns. Of course, there are hundreds of design patterns, and there are test automation specific design patterns as well. But I think it's very important to know at least the existence of the 23 different design patterns. You don't have to know all of them by heart, but it's good if you at least know some of them. And so what are design patterns? When people were struggling with some problems of their projects, then they realized that actually some of those problems occur in other projects as well, in other companies as well. And they realized that, okay, there are commonalities in between them, and the solution for them is very similar. So that's why they created the four of them and published it in the middle of the 90s, this book where they talk about design patterns. So this is how they look like. So there are creational, structural, and behavioral design patterns. I think for test automation engineers, it's mostly the creational design patterns that will be useful and which we use in our daily work mostly. Structural again is very useful. Adapter, facade, and proxy. I'm pretty sure that many of you who know the design patterns have already used at least one of them. Behavioral is probably not as commonly used in test automation as the creational and structural ones, but I think they are still very important to know. Of course, if you think otherwise, please let me know and share your opinion and experience. That's what I've seen in my experience and with the people that I talk to. And my favorite out of these 23 patterns is the facet pattern. And the reason is because there are several reasons for this. And one of them is because that makes you understand the tri-layer testing architecture concept more easily. And same with the flow model pattern that I talked about in July on the previous Z night. So the facet pattern, what is it about? It is about making sure that you can wrap some code that you don't really want to expose. You don't want the details to be exposed because it's unnecessary. What matters is that anybody using that facet, calling that facet, is able to use it in their code. And in testing, it happens in many places. And actually, the page object pattern is basically based on the facet pattern as well. This is a test automation specific design pattern, and I'm pretty sure that almost all of you have already heard about it and have already used it or have seen others use it. So this is right now the most popular test automation design pattern. And the concept is about you have all sorts of different pages, and for each of those pages that you are going to interact with in your test automation, you create a model, a class file, and you only store those elements and their locators that you are going to interact with. But you are also going to store all the user actions as well. So this is breaking the single responsibility, and that's one of the reasons of many other as well, why I came up with the flow model pattern 7 years ago, at around the same time when I came up with the idea of a tri-layer testing architecture. So what is the flow model pattern? Flow model pattern is basically very similar to the page object. The huge difference is that so instead of having everything in one class file related to that page, instead you have several different structure files and you have separately user flows. So and oh, the coloring is incorrect here, by the way, so sorry about that. Anyway, so the main screen, the toolbar widget, menu widget, login screen, profile screen are all structure models. You can call them page models or screen models. Uh, what it matters, it's showing you the state where you are right now, where you are sitting right now. And the flow models are showing you the directions that you are going. You can go back to that same page using interacting with the same widget or staying on the same page. And so this looks like or is very similar to a UML state machine diagrams. And instead of storing like everything in the login screen, in the login model, you instead have the news actions in separate user flows, and you also have the flows, the concatenated steps in the same flow as well. This way, uh, the logic is separate from the structure. So, going onwards, I'm going to show you some more automated testing techniques that are being used. And basically, there are several different test case automation approaches. This is very similar to what you can see in the ISTQB advanced level test automation engineer syllabus. There's a little bit of difference. I kind of made an unstructured version here. So instead of linear testing, I have generating the code and unstructured, and I don't include model-based testing here. The reason is because that's very different from all of this. Of course, that's part of it, but that's not really the scope of the tri-layer testing architecture. I'm going to talk about that a little bit later, but that's also very important to know. Anyway, so the first one is record and playback. In record and playback, what you do is you manually execute your task case, and whatever you do is being recorded. so you can play it back anytime you want. The problem, so it's very easy to use it, very quick to create test cases. But the problem is, whenever something changes, you have to redo the whole thing. So obviously, this is only useful if you have just a set of test cases to record, and nobody knows how to create test automation solutions. Then obviously this is your only choice. But for real test automation, this is not a solution to go with. The second one is generating code or creating unstructured test automation. Generating code means that you are still doing the record and playback, but code is generated that you can access and you can change it. So the good thing is now you are able to change it, but if you do it in an unstructured way, the problem is that you don't have testing libraries, you don't have the data separate, and so on. And because of that, this is not maintainable in the long run. So this is slightly better, but it's not maintainable. On the other hand, I have to mention that if you have a recording tool, you can still do structured and data-driven keyword and so on kind of testing. So it's all up to you. So I think it's better to mention that this is an unstructured way of doing it. Structured is when you have testing libraries. Data-driven is when you have the data outside. So it's not in the test cases. They are not kind of wired in, but they are being used from a database or from an Excel file or whatever other kind of file. The keyword driven is when you don't just have the data separate, but also uh, the steps are defined by keywords, and your test automation solution is able to recognize those keywords and run the necessary steps. So the good thing here is that so manual testers who don't have test automation knowledge, who don't have coding experience, they can still contribute to test automation because they create these files, and you as a test automation engineer will create the solution to be able to understand those files. Mostly people are using Excel files, but other solutions are possible as well. Process-driven, most people would think about BDD, but other process-driven approaches could be used as well. So process-driven, what it means that test automation is not just part of it's not just done by the test automation engineers and not just by the testers, but the business is included as well. So they create scenarios basically by defining the business requirements, and you can use those in your test automation. And the Gherkin language is used here. So the given when then scenarios and there are so I won't go into details with that because this is probably another topic or another set of topics. It's really huge. So in a nutshell, these are the approaches that the Aztec UB defines, and I'm going to talk about the unstructured way of creating test cases. I mean, automated test cases. So the problem with the unstructured way of doing it is there's no architectural concept. Therefore, there are no separate layers. Everything is in just one layer. Uh, and most of the times it's just a big, huge library, or maybe there are no test libraries at all, and it's just a mess. So it's impossible to scale, it's impossible to maintain. The good thing is that if you are doing a POC, this is going to be a good approach because unless you want to prove that a certain test automation architecture concept is good, then this is the way to go. If you want to, for example, do a tool evaluation and say that a certain tool is better than Selenium, then how can you compare the two? If the only way is if you do that, use both of them and see, okay, what are the capabilities of that given tool. Or you heard about a new tool, it's fancy, you want to try whether it works. You're not going to create a whole test automation solution. You're just going to write some test cases and see whether it works or not. It's also good if you don't have automation effort. So you don't have a dedicated test automation engineer. Developers don't have the time to maintain the test solution, but luckily there's no need for that. Then just create some test cases with it, and that's all. Also, if you don't have much coding skills, again, have seen some manual testers who have just a little bit of coding skills, and they create test automation with the help of the developers, and they only just maintain the test cases basically with the test data. That's all that they have to do. But you can clearly see that this is something that is going to fail if you want to do a bigger scale test automation. And this is how it looks like when you try to do it in a real big project. It's going to be a huge mess. And by the way, on the left, you can see me from yesterday. Just kidding, so from several decades ago. And on the right, it's my godson from some years ago. So, test case automation approach is continued. We're going to look into the structured approach right now. So, the structured means you already have libraries now, which is great, which is a huge difference. So, and I have to mention, so it does not necessarily mean that the pile architecture can be used only can be only a structured test automation. You can use DDT, KDT, BDT. It's your decision. So this is how it looks like. Normally, like in a UI test automation, you're going to have page models. In API testing, you're going to have utilities, as an example, product dependent libraries, and mixed libraries that are kind of have a lot of independent methods that could be used by other projects as well, but you also um, wire in some product-related calls, like a certain alert or a pop-up that obviously only appears in your application, but not for others. So obviously they wouldn't need it. So the biggest problem that I have with this approach is that this is the most commonly used one. And I know that some people might feel upset because of me saying this, but I think it's a huge mistake. And uh, I must say that if you are doing it, it's good. I don't say that the bilayer testing architecture is going to make you fail, because if you are doing it correctly, you're going to have a really good test automation experience. On the other hand, and especially for bigger organizations where there are bunch of like hundreds of different test automation teams, uh, this is something unacceptable in my eyes. And the reason is because it's reusability is circumstantial. If I approach you, ask you, hey, I heard that you have a really neat Android test automation solution. Can I use it? Then you said, okay, yes, Peter, you can do that. But here are my libraries. You have to take a lot of out of it because you don't necessarily need them. And because those libraries are most of the time are going to be big, it's also a little bit more time consuming for me to understand it and for me to get rid of all the stuff that I don't need. Or if it's a project where there are client related information that I'm not allowed to see, then everything needs to be done by that person. That person needs to create a new solution which only has the application and project and client independent solution. So that means that person would need to create everything from scratch for me. So redoing basically the whole work. And that's not a good thing. And when I still see people using it in bigger organizations, this kind of approach. I'm not satisfied. So let me show you the tri-layer architecture, and I hope that this is going to help many of you to improve your test automation solutions and to help your colleagues. Because if you have a really fancy test automation solution and your colleagues would like to use it as well, and if you are following the tri-layer architecture concept, then you can easily give that solution to them. And let me just have a little bit of water. So this is a concept that I came up with 7 years ago. So the whole story, how it looks like. I worked for one of the biggest sports clothing companies who at that time had the biggest fitness application in the world. And they had several different fitness applications, and they wanted to make sure that they can validate their scenarios and the UI of their mobile applications, iOS and Android and Windows Phone as well, in an automated fashion. So I first joined one of their iOS teams, and so I rebuilt that test automation solution from the framework wise, not the whole solution, but just the framework. That's when I started using the flow model. And then they said that they were satisfied with my work and they would like to see that on the other iOS project as well. So I was thinking how I could do that. And that's when I realized, and I think this is not like a big thing, but that's when I realized that, hey, actually we could have a common code, a common layer, a core layer, which both projects would be using. So all of the libraries that are application independent, and all of the libraries that are project dependent would be moved here. And anything additional libraries like, for example, related to GPS or device handling or the mocking those sensors could be also stored here. Um, and the reason for that is because if you store everything in a separate layer, you can right away give it to anybody. Of course, if you are allowed to do so. So first you have to make sure that there are no law breaking in it. So this is something that your company needs to have a, a heads up from the client if it was created for the client. If it wasn't, then if you create it for your company and you just reuse it in your different solutions, that's allowed. So this is something that you have to first make sure that it's okay to do it. So what you can do and what we did in the future, we had several different open source solutions, which now companies are using, not just our clients, but other companies as well, and other outsourcing and solution architecturing companies as well. And what you can do is have your base test, base page, base URL class-wise here, and whatever you want to add that is uh, your application dependent, you would just override these functions, and or if you need to pass certain values, then you would pass it in, like let's say fitness-based test. Let's call that a application as fitness, and you would have your fitness test or fitness-based test class file, which will be inherited from the base test. Same with the base page, you would have a fitness-based page, and so on. And regarding the logging, normally what I see most of the time, logging is something which you don't have to create your own version, but if it's necessary, you can do that as well. So anything that you would like to see be uh, extended, you would extend it in the business layer. That's where you will add all the additional stuff to those libraries. And other than those base models, you would also have your flow models and structure models here. Or if you are using the page object concept, you would have your page models here. That is how it looks like. And all the runnable tests are in the test layer. So, and the test suits as well. Let me go back to the tri-layer architecture just for you to see the whole in one picture again. So the core layer is including all the stuff that you can use in other projects or inside the project for other products. Uh, and this, so it, if you do it correctly, you don't have to do anything else other than giving the libraries to your colleagues. If you have to do anything additional, then that means your abstraction wasn't correct. You didn't design your architecture correctly. Uh, Anything that is in the business layer should not be used in any other applications. You can use it as an example, but all the details are here regarding your application. Your data would be stored here, test data as well, or in the test layer. I myself, by the way, like to think of it as something that is here. Again, it's all up to you how you organize it, but I myself like to have the test cases here, the test suits, and the test data. But test data, it's very important. It should not be part of the test itself. It should be separately stored. Of course, at the beginning, it's okay to do it while you are creating your first test solution, but it's better to just separate them. Okay, so going through, and again, what's very important, this is something that you can use this concept not just for UI testing, but for API testing and other kind of testing as well. So let me show you the ISTQB's version of architecturing. This is very important because it was released at the end of 2016. So I'm not the first one who thought about uh, a concept of correct layering, and and I'm not sure if I'm the first one who thought about a core layer, but probably not. I don't know. So I don't know that for sure, but I know that other people at the same time or around the same time thought about similar concepts as well. Um, but how the ISTQB's general test automation architecture looks like is a four-layered architecture. Now you would think that means that it's it's the same as the tri-layer testing plus one more layer. It's not exactly like that, but it's almost true. Let me show you a comparison. So in the test layer, uh, you can basically align it with the test definition layer. So for me, test conditions, test cases, test procedures, and test data are the things that are stored in the test layer. The test libraries is something I would move to the business layer. So I think that's separate. I think about it as a separate layer. Uh, Now, the core layer is something that can be aligned with the test execution and the test adaptation layer. So I myself merge it together in one layer. That's how I think about it. Because but on the other hand, some parts of it is going to be in the business layer because you are going to pass through values that make you be able to run it against your application in the given environment that you wanted. But that given environment, again, is something that you are going to probably configure in your CD. So you are going to create a project, let's say in Jenkins or whatever other tool you are using for that. And that's where you're going to configure the environment version if necessary, which test suite you are going to call from the test layer, and so on. So that's all up to configuration management. And I didn't include it in the trial test architecture because I think that's not part of the test framework. That's interconnected to the test framework, just like how ISTQB defined it as well. This is part of the test automation framework, these four layers, and everything else is interconnected to it. So, and I promised that I would talk about a little bit of the model-based testing again, and now I come back to that topic because you can see that I did not mention the test generation layer in my concept. There are two reasons for it. One, manual design I think is not part of automation. It's part of the whole process. So it's part of the process of creating test cases. And because of that, it's connected to test automation. But this is not an automated fashion, or this is not something that you are going to write in a code. You are going to design it, and then you are going to use it either by rewriting the whole thing as a test script, or if it's a BDD scenario, then you can just copy paste it or have a way to generate it as a code. Same with the model-based testing. The model-based testing is about generating all the test data and the test scenarios. This is something I don't have experience with it, and there aren't too many companies who are using that approach. It's very good because it's the most advanced way of creating test cases, uh, but it's very difficult to apply it to most of the projects. So that's why it's not mentioned. If it was, probably it would be part of the it's hard to tell where it would be. Probably it would be part of the core layer because you would include the model-based testing tool, right? So that's what would create the tests. On the other hand, you would need to be able to reach those models. So conceptually, it's very difficult to put it into the tri-layer testing architecture. Um, Conceptually, you might add it as a fourth layer, as a model generation layer. So, in conclusion, and I see that I'm almost out of time, so let me quickly go through these items. So, the tri-layer testing architecture gives you an improved abstraction and reusability, so it's much easier to reuse inside your project, in other teams, or even outside your project. Or if you are doing a collaboration, not just inside your company, but other companies, you can easily create a very easily reusable solution that is built on Selenium, for example. It helps collaboration as well. Also, if you create a core solution, other teams may collaborate and implement new libraries in that core or improve current libraries in that core solution. It also obviously reduces costs. So normally, a really advanced test automation solution takes several weeks or months to implement, and you're always going to maintain add new things as you are on the go. And you can make sure that you can kick off a new project quickly if you already have a core solution, and you can save probably a month or even 2 months if you have a very adequate test solution and a core layer of that. And also a good thing, this approach, the trial testing architecture can be used on all levels of the pyramid. Obviously, mostly in UI and API. It has the most sense in using it in UI and API levels or service levels. And I would like to thank you for being here with me and listening to my session. So all the questions that you have, I'm really curious to hear them. And you can reach out to me on several different platforms. I would recommend mostly Twitter or LinkedIn because that's where I can more easily answer questions to you. So I have a new Twitter account now. It made sense to finally create it. And on LinkedIn, if you add me, I'm really happy to talk about software engineering, testing, quality, and test automation. So anything that you are interested in, I'm really happy to share my opinion with you. And I'm also open to hear your opinions. So this is how the trial testing architecture looks like in a nutshell. Uh, and if you have any ideas, any opinion about it, please let me know because I'm always curious to improve this methodology, this design concept, and maybe you have something similar in your mind, and I would be happy to hear that as well. And if you are interested in my life in the US, we are trying to travel as much as possible here to uh, search new areas, to um, to go to the West, for example, and feel like Western people from the Western movies. So I have some pictures there. So if you are interested, you can, of course, go through them or add me. And if you want to listen to my previous talks, you can find me on YouTube as Peter Foldhazi, and you can see all the uploaded videos. Most of them are in English, but you will find some Hungarian as well. So thanks again for being here, and I hope you enjoyed this session, and I hope that you could take away something that will help you in your test automation journey. So have a lovely day or night. Bye. Sorry, in the meantime, I heard that I have one question, and let me use my phone to get that information, and then I will. Okay. What is the pyramid? Why it is applied to all levels? Okay, so that's the first question. So the testing pyramid, there are several different concepts what the testing pyramid is, and so how it looks like a pyramid, and the RSTQB defines it as a unit or component level, then integration, system, and acceptance. Some other people define it as unit tests, service or API tests, and UI tests. Some people add manual tests on the top. So you can have your own version of the testing pyramid. What matters is that mm, you analyze your project, what you already do and what you would like to do. Normally, I like to look at it as unit tests, API tests, and UI tests. I think that's more of the modern way to look at it. And the reason why the testing pyramid concept is important to know is because this way you see that, okay, you want to have more of the unit tests. That's why it's below and it's the wider level. You want to have still a lot of service level tests, but it's not as much, not as many as the unit tests. And you just want to have a little bit of UI tests. On the other hand, that's not always achievable, or that's not something that you want to achieve in all of your projects, because some of the projects are very UI heavy, and you need to validate more on the UI level. But in an ideal scenario, you move your tests down, and this way you are able to approach shift left, the shift left concept. Mm, and I think why it is applied to all. So why the second part of this question is why it is applied to all levels. You mean the tri-layer testing architecture? Okay, so the tri-layer testing architecture. So how I do it, I I so there are several ways you can use it. How I like to use it is I have one architecture for or one framework for the UI levels, then another one for the API levels. Other people, and of course it depends on the project, And in some projects, I did that as well. Some people mix it together. Now, the very important thing is that you have to be very, very, very careful what is common. So you might have the core layer a little bit wide and build the UI and the API above it, uh, the UI and API test automation solution. And you might have commonalities in the business layer as well. So that's how it would look like. And I'm glad you brought this up because probably I need to improve my presentation by including that picture, that diagram. So it will make it easier to understand how it's doable. So if you want to make sure that it's easier to understand, just keep it separate ways. If you want to reuse as much as possible, then you can kind of concatenate or merge the levels a little bit. And I don't know if there are any more questions. Let me ask. Just give me a moment to see if there are any other questions. There are no other questions, and as I see, I'm 2 minutes past the original time. So, in case you have any more questions, please send them towards my way. I'm really happy to answer all of them. And I wish you a pleasant night and enjoy the rest of the Z nights. And be sure to stay connected. And tomorrow there's going to be some other sessions as well. So, thank you and have a lovely night.